Good morning, everybody. Welcome back to lecture number 25. Before we begin, I would like to revise some concepts. We started before with the op-amp without any feedback. Without any feedback, we only have these three characteristics. Input impedance is infinity for the just the op-amp, الchip لحالها, when you connect two inputs. Zero output impedance. Why it's zero? Because it can drive any output, and it has an open loop gain of infinity on paper, big number in real life, to a point that it shouldn't exceed the supply. Note that if there is no negative feedback, the summing point constraint does not exist. In other words, the positive terminal would have a voltage, the negative terminal would have a voltage, and they will not equal to each other. When are they going to equal to each other? When we have inverting amplifier or non-inverting amplifier, both cases, as long as we have what we call a negative feedback. The fact that we have a negative feedback, the negative input and the positive input, they should be equal. In other words, the voltage drop between the two terminals is zero. In other words, a short circuit exists between them. In other words, if there is a ground here, there will be a virtual ground there. If there is an input here of V input, it will appear here. If there is a ground, if there is a resistor connecting, if there is another source here, it will appear here. If we have here, for example, V2, the negative feedback would force the negative input to have V2. Get it? Bottom line, what I want to say, as long as you have a negative feedback, the summing point constraint exists. What will happen if you have a positive feedback? What if this feedback was fed to the positive terminal? That's the story of today. But before we begin, let's do quick simple example, or we continue the previous example that we did last time. Now, do you remember this two-stage example? Hamad Khaldi, do you remember this example? We had here what? Inverting amplifier. Then we had what? A summer. It sums two inputs. So without doing complicated circuits, you can know that the output is 4 V1 minus 2 V2. And we did a numerical example here. Then we talked about the non-inverting amplifier, which implies that we still have the negative feedback, but the input now is fed through the positive terminal. Now looking at this curve, this figure, you can, in your own notes, connect these two, okay? This was a figure typo, okay? Then we talked about the voltage follower, which reminded us about the example of stereos connected to the car. You don't want to ruin your stereo system. You just want to get the power from via the op-amp itself. And in fact, if you have any big event, for example, the graduation ceremony, who's graduating this May? Congratulations. Anybody else? Yazan with you? Or your brother with you? So they have big audio amplifiers around the stadium, okay? So always when you walk, remember the voltage follower, okay? We also talked about this example, and we said we will start with the closed circuit. So this one is what? This one is an interesting example because the input is fed to the positive terminal and is fed to the negative terminal. So it's kind of a hybrid problem. And then you got a switch here. But also we verified the existence of a negative feedback. Because we have a negative feedback, V negative equal to V positive, or we call it Vx, the voltage drop is zero. Now when you close the switch, here we have a ground. This implies that we have a virtual ground here. Okay? And how did we analyze the circuit? We started with I input equals V input minus virtual zero over R. Everything here is R. And we said I2 equals to what? I2 equals to V input minus an actual zero, ground. This is an actual ground. This is a virtual ground. Over R. So both currents gonna split. But we know that no current enters the op amp. So I3 equals to I1. And you know that I input is I1 plus I2. So what is the gain? The gain has been calculated to be, because you know I3 is V output minus, I3 is 0 minus V output over R, 0 minus V output over R, equals to I1, which is V input over R. R would cancel, so V output equals to negative V input, and the gain is -1. The input impedance is V input over I input. You already know what's V input. What is I input? Is I1 plus I2. What is I1 plus I2? Is V input over R plus V input over R. So you get the R input impedance is the parallel combination between two R's, which is R over 2. If this was R1 and this was R2, what will be the input impedance? R1 parallel with R2. Okay? Get it? Remember, we solved this example when the switch was closed. What will happen if the switch was open, which is part A of the exercise? When the switch is open, we want to look at this circuit. Jihad, can you read the circuit? Can you see it? Or do I need to zoom?
No.
You can see it? Okay. Ramadan, can you see it? Okay, I don't want to lose the text, that's the problem, but maybe that's enough. Okay. So there is a question here. What is the voltage at this point? So here we don't have a ground. So here we don't have a virtual ground. So we notice that Vx is non-zero. So it's some sort of voltage. But we are very smart, right? We are very smart. We don't give up. Then we know that there is no current that enters the op amp. صح ولا لا? Because there is no current that enters the op amp, the voltage drop across this resistor is what? Zero. There is no current here. So technically the voltage drop here equals to the voltage drop there. Let me repeat. We all agree I2 is 0, right? We all agree I2 is 0. I want to know what's the voltage drop here in reference to the ground so that I can mimic it here, because we have a negative feedback. Because I2 is 0, the voltage here is actually the input. You don't believe me? You have to be the KVL. Awal. You're the KVL guy. So let me draw this circuit. We're professionals, we do everything right. Okay, let's do the labeling. Father, please help me with the labeling. We have here what? I input. And here we have everything is R. Plus minus, plus minus, plus minus, plus minus. Here we have
I1 and
I2 equals 0. Here we have I1 equal, we don't know yet. Here we have
I3.
I3 plus or minus, and here we have the output. Here we have output. And what is this current we call it? Ix. What is the voltage drop here? Vx, okay? So I want you the KVL, you're gonna start from, so what's your, في ريحة دخان ولا يتهيألي؟ طيب, let's start from here. العواد, what is your path? You're going to go here. Then you're going to go here. Then you're going to go here. Then you're going to end in the ground. صح? You agree with me? Yeah. Okay, let's do it. What's the voltage drop here?
Zero.
No, not zero. That's why we want to do this exercise. Is this zero? This is open cable. مقطوع. It's not connected to the ground. So what is the voltage drop here? Vx. What's the voltage drop across this resistor? Write the formula. Plus
I2.
Plus I2 R. What is the voltage here? Drop?
Minus IN.
Minus VIN. You don't say IN because we don't have a resistor. We have a voltage source. Get it?
Yeah.
So equal to
Zero.
0. I already told you, op-amp cannot allow any current to enter. It blocks the current. Because it blocks the current, I2, it has no escape path. So there is no I2. So I2 is what? Zero. So what do we have? Vx equals to the input. Interesting. Now, if Vx equal to V input, we already know that this is Vx. What is I1? What is the formula of I1? No, not IN. That's the trick. Who said IN? That's the trick. I am telling you Vx appears here from Al-Awad's KVL. And I'm telling you, because of the negative feedback, we have a Vx here. If you have a Vx and Vx, can there be any current flowing? No. So I1 equals to what? Vx minus Vx over R, which is what? 0. So because I1 is 0, I2 is 0, IN is what? 0. There is no input current. There is no input current. And what is happening is, there is no current here. There is also no current I3. So I3 is also 0. So the only thing is I have V output is just physically connected without the current flowing to V input. كأني موصل node, big node. So V output equal to V input. You don't believe me? V output plus 0 equal to V input. Because there is no voltage drops across those two resistors. Get it? Did you want me to do a big KVL here or no need? So يعني كأنك موصل كيان. So what's the gain if V output equal to V input?
1.
Plus 1, okay? So now, without reading these complicated things, I know because there is no current flowing here, V output is just equal to V input. Plus V output, plus I3R, plus I1R, minus V input equal to 0. But those two are 0, so V output equal to V input. Okay, what is the input impedance? Easy. Shaheen, V input over I input. What is I input?
0.
So what's the input impedance? Get it? What's the output impedance, Abdul Majid? Does the gain, which is plus 1, rely on R load? Is there R load in the gain equation? معناتها ايش؟ معناتها زي سماعات السيارة. It can drive whatever output, and it gets Ix, which is this one, from the supply. And this Ix is what generates the output, and it mimics the input signal. هذه كأنها voltage follower when the switch is open. Okay? You're late. And you're absent. Okay? You can attend the second lecture. It's up to you. Get it?
دكتور كذا لدينا فائدة الامبليفاير.
Well, فائدة الامplifier, you want to get some sort of relationship between the output and the input. تبغى تمرر السماعات من هنا لهنا. But you don't want to get the current driven from the input. You want to get it from IX. That's why you have an output impedance of 0. Get it? Now, these equations are similar what I told you again, because I3 and I1 are 0, V output equals to V input plus V output plus I3 R3 plus RI1 minus V input equal to 0. I wanted to do this KVL with op amps. Okay? So any question about this problem? This is a very interesting negative feedback problem. Inverting and non-inverting together, okay? So remember, quiz 5, when it's going to be?
Last Thursday.
Tuesday class. Okay? Because you said, not you. Many of you say they don't. You agree?
Yes.
So the quiz 5 is not this Tuesday, the following Tuesday. We want to have, my goal is to have 9 quizzes so that we can remove 2. Okay? Up until, I don't know yet. It's definitely the op amps.
دكتور خلي الماتيريال اللي هي مو شرط. ماتيريال.
ماتيريال على ايش تبغى؟
كويز.
على أي chapter؟ مع الأوب أمب. Because I want you to study the op amp. You already studied chapter 5. تبغون حق الباور؟ تبغون حق الباور؟
لا.
Chapter 5.
No, it's too. لا. The op amp. Op amp. No. We'll decide. Chapter 5 you already studied, okay? Later at the end, when we run out of quizzes, maybe I will do special case quiz where we'll pick, I find a chapter that I find you guys really weak at, the average is low. We're going to have another quiz. That's, I think, the best. But for now, I want you to study this for the midterm, okay? How many of you did not study? Raise your hand. I'm not going to judge you. I'm not going to take point. How many of you did not study chapter 5? Especially the power part. Raise your hand. That's okay. You did not study the power part. You have to study it before you go to the amplifiers, okay? You have to watch the additional lecture and you have to also you have to study the op amps. Another interesting example in the okay. Is this inverting or non-inverting?
No.
It is non-inverting because the input is fed to the positive. Does it have a negative feedback?
No.
Yes, negative feedback. The output is fed back to the input. It doesn't mean literally the output, the whole output. It tells you there is a path of resistors, capacitors, etc. that connect you back to the negative input. Now I have the summing point constraints. V positive equal to V negative. But we are smart enough. Because V input, what's the voltage drop at the positive terminal? V input. Now we have what? We have also here, what's the voltage drop here?
Yeah.
It is also what? The input. Right? Note that we have a voltage source that does not put any current because this is a characteristic of the op amp. It doesn't allow any current to enter. Okay? So we have V input here, 0 current here. We also do not have current here. Yes?
Is it always that the negative side is V input?
No. Not always. لا تعمم في الأوب amps لا تعمم. You have to play with the rules. The rule says the first step is you have to know it's inverting or non-inverting or both. We know it's non-inverting. Second rule, check the negative feedback. We do have something from the output that goes back to the negative input. Because of the negative feedback, V positive equal to V negative. Then you have to see, can I know V positive? Yeah, it's V input. Then it implies V negative is what? 0. Because V negative is 0, the voltage drop Vf equals to V input. Again, Vf equals to V input. So that's the first step, is we have what? Vf equal to V input. And again, why did we call it Vf? Why the letter F? مش على الغامدي. Why there is a letter F here? Because of the feedback. Okay? Why there is an L letter here? Because it's a load. Get it? Why there is an N here? Because it's an input. Why there is an O here? Because it's an output. Get it? So V input is mirrored on the V feedback. So this implies I can calculate IF. What is IF? Is VF over RF, which is V input over RF. That's the first equation. From these equations, we all know I output. Can I output swim inside the op amp? Sadiq? You're Sadiq? Can I output some of it swim inside the op amp?
No.
Why? Because op amps المثلث بيحجب الكرنت. مثلث بيحجب. So I output is what? I output equals to IF. N equal out. What is N? I out. Plus 0. What is out? What is out? IF. So I output equal to IF. Do you see it? Or you don't see it? That's okay. Yes or no?
Yes.
Do you see it? If you don't see it, that's okay. I output equals to what? IF. So what's the equation of I output? V output over R load. Do you agree with me? But it's equal to IF, which is V input over RF. So our goal is to find V output over V input, which is clearly RL over RF. So that's the gain. Not that this is not written in the slide. Okay? Because the question was asking about what's the input impedance. Adnan, what's the input impedance?
0.
V input over I input? No, not 0.
I think
So the input impedance is V input over I input. What is I input?
0.
So it's V input over 0, which is infinity. So we have an infinite input impedance. And Father, what's the output impedance?
Output impedance.
Yeah. It's non-zero. Why? Because the gain for the first time depends on the load. So this is not a lovely circuit, because if you connect a big load, you're going to get a big gain, subject to the supply constraint. So we can see we conclude that the output impedance of the amplifier is infinite, not 0. Because we have the load in the gain equation. Okay? From these equations, we find that I output is written. If you find the relationship between V output over V input, which is not written here, it is RL over RF. Because the gain has R load in it. Okay? The output impedance is infinity. We conclude because I output is independent of R load. This is I output. Remember before, what did we say? When we have V output is independent of R load, output impedance is 0. Here we have I output is independent of the load. we conclude that the output impedance of the amplifier is infinite. The input impedance, already Adnan told us it is 0. Okay? So what's the output impedance?
It's non-zero.
Is infinity. It's not 0 or infinity. Both are correct.
Doctor, is it infinity because it blocks the current inside?
No, because it acts like a current source. Whenever you connect a load of 5, okay, you already know V output is what? V input times a gain. That gain increases. If you connect a big load, that gain increases. So it allows you to have as many current as you want, subject to the supply constraint. Okay? That's the key about it. Honestly, what's more important is not the output impedance. What's more important in this circuit is how to calculate the gain. And that's why I wanted to solve this problem, because this solution here does not show the gain. So this acts like what? A current source. Okay? Then we have another complicated circuit. I'm taking my time in the inverting amplifier. Abdul Majid. What was the gain in the previous circuit? RL over RF. Because the gain has an output impedance, the load appears in the gain, the output impedance is infinity, non-zero. Okay, or a non-negative number. You want to do this complicated circuit? Wow. فيها square, وفيها multiplier, فيها etc. So let's try to solve this circuit. I am not going to draw this circuit. Instead, I'm just going to try to solve it, okay? And now, I really need to have my notes so that I don't mess it up, okay? Let's begin. Where is the op-amp? Here. YouTube, focus. This is a tough example. The Majid, focus. This is a tough example. Is this inverting or non-inverting? Why? Because the input voltage enters through the positive terminal. Step number 2, check the negative feedback. Do we have a negative feedback? This is the output.
Yes.
We have some sort of connections. The key word is some sort of connection back to the negative input terminal. What does it mean? It means the positive voltage equals to the negative voltage because of the negative feedback. So here we have V input. Then what do we have here? V input. So V input equals to V1. That's the first equation. V input equal to V1. Okay. What is the current that enters here? 0. What is the current that enters here? So what's the current that enters here? I1. I1 equals V1 over R1, which is V input over R1. That's good. Now,
Shouldn't we add the second current?
no, we don't add it because this is also I1. So I1 would swim, Mish'ar, would it swim inside the op-amp? Huh? So this current would swim all the way to the ground. So this current, which we call it I1, equals to this current, which is also I1. Okay? So this is also I1. It's V2 minus V1 over R2. Okay? Note that here we have R1, here we have R2. Here we have R1, here we have R2. Here we have RL. شوية مخلوطة. R1, R2, R1, R2. Get it? I don't care about this I1 because I already have an equation for it that links it to V input. Your goal is to carry V input all the way to V output. Get it? Okay. Do I need to calculate I1 one more time? So let's calculate V2 or I2. What is I2? Is V2 over
R1.
R1. Okay, I still need to calculate V2. Who wants to be the KVL? Khalid, you're going to be the KVL here. How many Khalidis we have now in this class? We have 3. صح? Badr? Oh, no, Asim is I think 11. No, Asim is here. Muhammad.
Azam.
Muhammad. So we have 3 Khalidis in this class. Record number. Okay. First time all of you together, Khalidis. صح? Okay. KVL. Where do you do KVL? هنا, صح? This is the...
That's right.
So, start. What's the equation? Plus V2. Okay. Do you want to put plus minus or do you want to put plus minus, the passive sign configuration? What I'm going to do is I'm going to do plus minus to escape the passive sign configuration. If I put minus plus, that's okay. It will the sign will take care of itself. What's the sign of it? Voltage rise or voltage drop? Minus I1 R2. And then here, what do we have? V1. But we already have an equation for V1.
VN.
Well, let me follow the book. Let's keep it as R1 I1. Okay? There is a mathematical trick I will show you why we're going to keep it. Okay? So, minus R1 I1. Get it? Can I say V2 equal to this plus?
Yes.
Okay. So now we know how to get this equation. What else we have? What is this current here? I3. How do you want to do it? Plus minus, okay? To avoid the passive sign configuration, okay? What is I3?
I1.
I3 is, no, it's I1
Plus
plus I2. Again, we have I3. Here what do we have? What did we call it?
IX.
IX. ذكروا IX is the one that هو اللي يخلي السماعات تشتغل. This one we don't like it because it's hard to be calculated. And here what do we have? I out. Get it? So we already linked that. So the only thing we have is to calculate the output. مش عندي. What's the voltage drop here?
0.
No, not 0. All of this point in red, the voltage drop across any point of this line is V output. This is V output. This is V output. This is V output. لما تحط الفولت ميتر هنا هل بيفرق لما تحطها هنا؟ It's all the same touching point. Very important concept. So what's V output? V output equals to, we have to do, I know it's IORL, but our goal is to connect V output with V input. This is the most important equation. Who wants to be the KVL? Shaheen, you're going to be the KVL. So we're going to start from here.
Plus
Let me change the color. Pink.
plus V out.
No, don't do it. I want to see the path first.
Oh,
Is this a good path?
yes. From
It's a
front
good
to
path.
front.
Huh?
They can open. مشي الباترون.
Well, it's not open. Here we have a ground, here we have a ground, so it's closed.
They can open.
What do you mean by
من V2. اللي بالوسط they can't open. نفس
that? It can open?
Yeah.
Yeah, you can stop here and call this V2. يعني ما في resistor?
Mm.
That's okay. Because if we say V2, it's measuring it with reference to the ground.
Oh.
Similar to Vx we had in the previous example. Okay, let me check YouTube. Is it working? Yeah. Khaldi Badr. and Shaheen, you both have to help me. So, plus V output,
Yes. Then drop minus I3 multiplied by R2.
minus I3 R2, and Khaldi, the last one, what is this? Yeah, what's the equation? Yeah, but write it in terms of currents.
R1 and
Okay, keep it as V2. Let's do it V2. So this will be what? Minus V2. Can I do, Shaheen and Khaldi, can I do equal and then plus?
Yes.
Basically, I'm shifting I3, R2, and V2 to the right. And here's the trick. And that's why I had this paper. We would use these equations to focus with me, Ashraf. We will substitute I3 using I1 plus I2, but also we will substitute I2 with what? V2 over R1. We will also substitute V2 with I1 times R2 plus R1 times I1. But we already had V2 in the I2 thing, so we need to put this again one more time. Okay, and I will show you how. It took me like 20 minutes in my office to write this paper. So focus with me. V output equals R2 times I1 plus
I2.
I1 plus V2 over R1.
It's I2 times I3. So it is R2 times I3. What is I3?
I1 plus also.
I1 plus I2. Okay? Plus V2. What is V2?
I1 R2 plus R1
I1
R2
R2 plus
R1
R1 I1. Keep the I1s for now. They are easy. The I1s are what? V input over R1. Okay? Can I say this is R2 times I1 plus V2 over R1? And can I say no. The mathematical trick is I would keep this as V2, okay? Okay? So this is plus V2. Get it? What I'm going to do right now is I'm going to call this R2 I1, okay, plus R2 over R1 plus 1 V2. Do you see? Do you see the mathematical trick that I did?
Yes.
You guys love algebra. I don't like it. So I kept V2. I want I2 as a function of V2. I took a common factor, R2 over R1 plus 1. That was the not obvious trick. Then everything should fall through, which is equal to R2 I1 plus R2 over R1 plus 1 times R2 I1 plus R1 I1. The only thing I wrote V2 as a function of I1. So everything I have here is I1, 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 all resistors and constants. So now it's going to be what? R2 I1 plus R2 squared over R1 I1 plus R2 I1. This times that, this times that. No, this. Yeah. Then we have plus R2I1 plus, so R2I1, R2 square over R1I1 plus R2I1 plus R2I1 plus R1I1. You all agree with me? And now, every I1 I should replace it with V input over R1. So this will be R2 over R1 V input plus R2 over R1 square times V input plus we have here R2 over R1 V input plus R2 over R1 V input plus this is R1, so this will be V input alone. Okay? Take V input as a common factor, so remember this was what still V output. V output equal to V input times. This is what? R2 over 1 plus R2 over 1 plus R2 over 1 is what? 3R2 over 1 plus R2 over 1 square plus 1, and that is the gain. It's 1 plus 3R2 over R1 plus R2. So this is now a squarer. يربع. It has the mathematical ability to give you the power 2 of the sigma. So now we have summer, we have multiplier. This is technically a multiplier. And it can look at it. It can even maybe give you some sort of x squared plus 3x plus 1. So it can solve equations. These are the bases of the computers. Okay? Now, if you substitute these values for the whatever numerical numbers they have in the exercise 13.6 in the book, if you open your book, YouTube, open the book, substitute the numbers, you're going to find the gain is 131. So in the test, we might ask you to calculate the gain, and then using these values, AV equal to that, okay? And by the way, we are still talking with Dr. Atiyah and Dr. Ahmed about Major 2, about the possibility of having some written question. But you know my position. My position is I don't like it. Because it's either problem 1 will be graded by Dr. Atiyah, problem 2 will be graded by me, for all sections, to be fair with everybody else. Forget about I grade your exams, Dr. Atiyah will grade his own exams, and then they get all the grades and I don't give you grades. We don't want to have this scenario, okay? So we will see. But there is a talk that we might have some sort of problems, but you know my position. I'm so sorry. I would rather have 50 questions that are simple, MCQ, than having one big problem like that.
It will be 2 written questions.
No, we don't know yet. We're still arguing, okay? What's the input impedance? Adnan, your favorite?
No, what?
Yeah, it's easy.
Infinity.
Infinity. Why? Because it's V input over IM. What is the output impedance? Your favorite?
It's non-zero.
No. Do we have RL here?
No.
No.
So output impedance is
Zero.
0. It means it drives whatever. Okay? So this acts like a voltage source. The gain is independent of RL. The output resistance is 0. The only example we have a non-zero output impedance was this example because we have RL in the gain. And here, because I output is independent of our load, we conclude that the output impedance of the amplifier is infinity. Now, when we say infinite, subject to the supply constraints. يعني مو تجيب له تريلر تبي تشغل بام صغير. Positive feedback. How many minutes? I would end with this slide, and then next slide we will warm up with this, but we hate positive feedback, okay? Because when the feedback is positive, the output quickly becomes saturated. يتشبع. At the maximum possible voltage, that the op-amp can produce, either plus VCC, plus 10, plus 5, or minus VCC, minus 10 or minus 5, depending on the sign between VI. Now, the trick here is, last name?
Salman.
Is Salman. In the negative feedback, I told you V positive equal to V negative. Is it that, do you think it's the same case for the positive feedback?
No.
No. Here we have a positive feedback. This VI, or we call it Vx, remember we call it Vx, is non-zero. So Vx is non-zero. ما في أحد في non-feedback amplifier ولا في positive feedback amplifier يقول لي V positive equal to V negative. That's wrong. I'm gonna repeat again. Only V positive equal to V negative when we have a negative feedback. Everything else, like the positive feedback, it's not true. Analyzing this circuit real quick, what is I input? It's V input minus Vx, or we call it Vi, I'm going to call it Vx to be consistent, over R1. I2 is what? Vx minus V output over R2. But I know that I1 equals to I2. Still, all the op-amps cannot allow any current to swim inside their input. They block the currents. So the feedback goes to the positive terminal. And if I want to try to find the relationship between V output and V input, I know that V input minus Vx over R1 equals Vx minus V output over R2. If I want to try to find a relationship, Vx over R2, this will be what? Minus 1 over R2 Vx minus 1 over R1 Vx. Okay? We will solve it next exam, in the next in the next lecture. But if I bring plus V input over R1 equal to minus V output over R2, what I'm seeing is the Vx tells us how much the gain. We don't know the gain. The gain, there is no closed form expression. We will solve it next lecture because you don't know what is Vx. Okay? You don't know what is Vx. The gain is, of course, the gain is positive R2 over R1 plus some components that leads it to saturation. And if you look at this example, try to solve it at home, you will find that you can find the relationship between Vx if you know V input. So, depending on how much input you provide, you don't know how much Vx. You don't know how much V output. You could be saturating at plus 10 or minus 10. باختصار, this is not straightforward. It's not favorable. The major thing you need to know is the output is saturated. We will do a numerical example next lecture. Feel free to go. Sorry for exceeding the time. Any question? Yeah. Any question?